In last video, we have discussed about specific heat and its units. Today, our concept is about applications of specific heat. Let's see about applications of specific heat. So, applications of specific heat means first take earth. Yes. So, the earth is covered up to 70% of water and 30% of land. We all know that earth is covered up to 70% of water and 30% of land. And sun produces huge amount of heat. Where sun produces huge amount of heat, who will absorb it? The natural resources which are present on earth, they will absorb that huge amount of heat energy. What are water resources which are present in on the earth? The water resources which are present on the earth are like oceans. Yes, just consider ocean as a water resources which are present on the earth. Yes, okay. So, just take an equator. At equator, the temperature will be more. We all know at equator, the temperature is more. When temperature is more here, where the oceans present near to the equator, will it be consist of hot water? No, because the water is having high specific heat. Though it is having high specific heat, it absorbs more heat and it doesn't changes its temperature much. Yes, water is having more specific heat. When water is having more specific heat, what happens means it absorbs more temperature, but it doesn't change its temperature more. That means the change of temperature will be less. Yes, the oceans which are present to the equator, it will absorb that heat and that heat will be transmitted to the poles of the earth. Yes, what happens here? The oceans will absorb that heat from the equator. After absorbing heat from the equator, that heat energy will be transferred to the poles of the earth. Yes, so why like so it is happening? It is happening because water is having high specific heat. When water is having high specific heat, it absorbs more amount of heat and it changes temperature in less quantity. Yes. Okay, so that's why we call these oceans as storehouses. What we call them? We call oceans as storehouses because why we call it as a storehouse means we store heat energy. Yes, on this earth, who stores heat energy means oceans will store heat energy. That's why we call oceans as storehouse. Okay, it is the first application of specific heat. Yes, and let's see second application. What is second application means? It is all about watermelon. Yes, it is all about watermelon. If our mommy brings watermelon, what we will do? Immediately we will take that watermelon and we will keep that watermelon into the fridge because to keep cool. Yes. So if in hot summer, if it is cool means it is ready to eat means we will have maja. Yes. So like so, take that watermelon. So keep that watermelon into the refrigerator for 5 hours. So when you keep that watermelon into the refrigerator for 5 hours, after 5 hours, if you want to eat that watermelon, it will be very cool. Yes or no? Yes. So when it is being very cool, can you eat happily? No, you will feel discomfort in eating watermelon. So at that time, what you will do? You will take out that watermelon from the refrigerator and you keep aside for a while. to keep. So when you keep that watermelon out of the fridge, will the watermelon will become hot? Will it become hot immediately? No. Though when you keep that watermelon out of the refrigerator, it absorbs heat which is present outside it. Yes. So though it absorbs the heat which is present outside it, it doesn't change its temperature. It stays cool for the long time because the watermelon will be having inside it water. The water which is present in the watermelon is having high specific heat. So when it is having high specific heat, what happens? That watermelon which is having water, because of the water it is having high specific heat. Though it is having high specific heat, it absorbs the heat which is there in its surrounding, but it won't change its temperature for a long time. It will be cool for a long time. Why? Because it is having high specific heat. It is the second application of the specific heat. And third application. What is third application means? It is all about samosa. Samosa. Don't be tempted. When you see samosa, even I also tempt for samosa. Yes? Okay. So samosa, when it appears before you, it look like cool one. But when you want to eat, if you eat that samosa, you feel very hot. Why? Why? Because the curry which is present inside the samosa is consisting some ingredients. Yes. So that ingredients is having specific heat. So when the curry which is consisting of ingredients is having more specific heat, automatically when you eat that samosa, it will be very hot. But outside when it appears, how it will be? It will be look like a cool one. But when you take the samosa, it will be very hot. Why? Because the curry which is having ingredients, they are having specific heat. Due to that specific heat, when you take that samosa, you feel very hot. It is the third application of specific heat. So what are the three applications of specific heat means? The first one is all about ocean, and second one is all about watermelon, and the third one is all about samosa. Okay. So why water is having more specific heat? Some of you will get doubt that why water is having a more specific heat. Yes or no? Yes, you will get doubt that why water is having more specific heat. Let's see about it. So take a substance. First, suppose that substance is water. Okay. Now we are going to take a substance, and that substance is water. So water will be having some molecules in it. Yes or no? Yes. Water will be having some molecules in it. So some molecules will be rotating, some molecules will vibrating, and some molecules will combine to form bond. They will form bond. Yes. So the water will be having molecules. Some molecules will rotate, some molecules will move randomly, some molecules will form bond, some molecules will vibrate. Yes. So these all are having some different types of energies. In where it is going to have these different type of energies means these different types of energies are present in internal energy. Yes, internal energy is not one type of energy. It is having different type of energy like vibrating energy, vibrating kinetic energy, rotatory kinetic energy, linear kinetic energy. Yes, internal energy is having different types of energy. It is not one type of energy. What are the different types of energies means? It is rotatory kinetic energy and vibration kinetic energy and linear kinetic energy. All together we call it as an internal energy. Okay. Yes. So which one will have internal energy? This water molecules will have internal energy. Based on that internal energy only we can say that substance is having more specific heat or less specific heat. Okay. So here we are having different types of energies. In that linear kinetic energy is also there. If linear kinetic energy is having in less amount, specific heat will be in less amount. That means the temperature of that substance will be less. If linear kinetic energy is more to that substance, then the temperature of the substance will be more. So here the linear kinetic energy is less to the internal energy of water molecules. So when linear kinetic energy is less, its change of temperature will be less. So when change of temperature of the water molecules less means the specific heat of water is more. That means when a substance specific heat is more means it is having linear kinetic energy is less in the internal energy. Yes, so when there is less linear kinetic energy in the substance, automatically what we can say? We can say that the temperature will be in less amount. The change of temperature will be less. Yes or no? Yes. So here the water molecules is having less linear kinetic energy. So here the change of temperature will takes place in less quantity. Yes. So here the water is having specific heat in high amount. Why you understood, I think so. So let me explain about this again. So what are the applications of specific heat means? About oceans. The first application is about oceans. The oceans will store that huge amount of heat, so that's why we call them it as a storehouse. Though at equator we have high temperature, the water which are present at high temperature like oceans will absorb the heat energy, but they will transmit that heat energy to poles of the earth, so it will no change in temperature. And second application is about watermelon. It will be cool for a long time because it is having water inside it. So the water is having more specific heat. So when water is having more specific heat, it will remain cool for a long time. And last application is about samosa. Though it appears as a cool one, but inside it, it is having a curry. It is consisting of some ingredients. That ingredients are having some specific heat. Due to that specific heat, when you eat that samosa, what happens? It will be very hot. So these are the three applications of specific heat. And why water is having high specific heat means the high specific heat is based on, the specific heat is based on internal energy. Internal energy is not one type of energy, it is consisting of different type of energy like rotational kinetic energy, vibrational kinetic energy, and linear kinetic energy. So when the internal energy is having less linear kinetic energy, then change of temperature will be less. So when it is going to have less linear kinetic energy, what we can say? We can say it is having high specific heat. So that's why water is having high specific heat. Next concept is method of mixtures. So let's see about method of mixtures. So to know about method of mixtures, we have to see three situations. So in first situation, what we have to do means you have to take two beakers. Two beakers should be in same size. And first beaker is containing 200 ml of water and second beaker is containing 200 ml of water. So same size of beaker and equal amount of water we are taking. The substance is also same, water we are taking. Next, and both the beakers should attain same temperature. Until they both attain same temperature, you have to heat the both beakers. So for suppose the first beaker attains 60 degrees means second beaker also should attain 60 degrees Celsius. So until they attain same temperature, you have to heat both the beakers. So after heating them, when they both attain same temperature, what you have to do means you have to take a big jar. Yes, so after taking big jar, you have to fill that jar with these two mixtures. So these two water. So this 200 ml of water should be poured into that beaker, and this 200 ml of water you have to pour to that beaker. So when you pour that 200 ml, what we get? We will get how much? 400 ml. Yes, so that 400 ml we poured into this big jar. So here what temperature it will have? Here it is having 60 degrees Celsius and second beaker is having 60 degrees Celsius. So when you mix both the water, so what temperature it is going to have? It's my first question. Next, let's see about second situation. In second situations, again take same size of beakers and again you fill 2 beakers with 200 ml of water. First beaker is having 200 ml of water and second beaker is having 200 ml of water. After taking water, what you have to do? You have to give some heat. So you have to heat first beaker up to 90 degrees Celsius. Next second beaker you have to heat up to 60 degrees Celsius. So when you heat first beaker with the 90 degrees Celsius and second beaker with the 60 degrees Celsius, what you have to do? Again you have to take a big jar. So after taking a big jar, you have to pour this 200 ml and this 200 ml into that big jar. Then you will get 400 ml. After pouring that 200 ml, you will get 400 ml. And what its temperature I want? It's my second question. Next, third one. Take a jar, take a beaker and take another beaker. So first beaker should have 100 ml of water and second beaker should have 200 ml of water. So after taking 100 ml of water, just heat up to 90 degrees Celsius and heat this 200 ml of water up to 60 degrees Celsius. So after heating 90 degrees Celsius and 60 degrees Celsius, what you have to do? You have to mix that water. So when you mix, what amount of water you will have? You will have 300 ml of water. Again, so what its temperature? When you mix that 2 beakers water, what temperature this big jar will have? It's my third question. Yes, so we have seen 3 situations of method of mixtures. In the first situation, what temperature it is going to have, I asked, and in the second situation, what temperature it is going to have, and third situations, what temperature it is going to have. So let's see about first situations. When you mix these two water, what happens? We gain 400 ml of water. So first beaker is having 60 degrees Celsius and second beaker is having 60 degrees Celsius. So some of you may think that 60 degrees Celsius plus 60 degrees Celsius. So this jar will contain 120 degrees Celsius. Yes, will it contain 120 degrees Celsius temperature? No, children. So it is totally wrong. So when it is going to have 60 degrees Celsius and second beaker is having 60 degrees Celsius, when you mix that both, you will get a temperature of 60 degrees Celsius only. Because, why? Because both are having same substance, water. And we are supplying heat up to where? Up to when it is going to attain same temperature. We are going to give only same temperature. And the substance which is present in beaker is same. So that's why, and also we are taking same beakers also. There is no difference. So when there is no difference in these three, there is no difference in temperature also. It will attain 60 degrees Celsius. So what's the first situation's temperature? Its temperature will be 60. It's not 120. It is totally wrong. In first situation, the big jar will be having 60 degrees Celsius. In second situation, what happened? Let's see. So the first beaker heated up to 90 degrees Celsius and second beaker is heated up to 60 degrees Celsius. Here we have taken 200 ml and here we have taken 200 ml. When we mix them, we got 400 ml. And what's about temperature? So already we know when one body is having high temperature, that will be transferred to the body which is having lower temperature. So what happens when you take this 90 degrees Celsius, it is going to be mixed with the 60 degrees Celsius. So what happens about this temperature? In second situation, this large beaker will have temperature below 90 degrees Celsius and above 60 degrees Celsius. Yes, when hot water and cold water mixed, it forms a warm water. That means the temperature will be between this 90 degrees Celsius and 60 degrees Celsius. Okay. And what about third situations? The first beaker is heated up to 90 degrees Celsius and second beaker is also heated up to 60 degrees Celsius. So again, when you mix them, what happens? What happens here also? The temperature will be between 90 degrees Celsius and 60 degrees Celsius. So in first situations, it is going to have same temperature, that is 60 degrees Celsius. In second situations, it is going to have between 90 degrees Celsius and 60 degrees Celsius. And that means it may have some 70 or else 75. In third situation, it is also having the reading in between 90 degrees Celsius to 60 degrees Celsius. Yes, we know about temperature now. Okay. We will see the mathematical calculations of method of mixtures. Method of mixtures means we are going to mix these. The first one and second one we are going to mix. When you mix, it is going to have what temperature we have seen now. Again we mixed these two. When you mix, what happened we have seen now. Again we have mixed these two. Again we have seen what happened. So method of mixture means we are going to add 1 plus 1. Yes, we are going to mix them. When you mix them, that is called as a method of mixture. So we will see the mathematical calculations of method of mixture.